There are two major categories of databases. One is called relational databases, and the other one is called non-relational databases. It's as binary as that. Relational databases are the usual stuff that you probably heard so far, like MySQL or MySQL, PostgreSQL, Oracle database, MS SQL, and stuff. There's no, it's not a coincidence that we have this SQL in the name. It means structured query language. It's basically some kind of a language to do, to query data, to fetch data. And MongoDB, on the other hand, is the member of the other group, the non-relational databases. And it's, again, not a coincidence, it's called NoSQL database because it doesn't have this query language. It's kind of a standard. If you want to work with data, you work with SQL, and you work with data structure that's supported. But then people said, this is actually not the way that we want to develop software. So when we are developing software, we actually want to have another structure that more resembles our objects and our application structure, and hence the name NoSQL. So it's like a pushback to the industry. So what this means, we can maybe say a few words about the topic relational databases versus non-relational databases. Maybe one of you could raise your hands and tell me what a relational database is, or what relational means. What do you think it means? How does it sound? Please.
That's the one database to another. Communication, exchange of information.
Exchange of information between two different databases. Yeah. And what does it mean when you hear non-relational database? That they cannot communicate, yeah. Any other, that's a good way of looking at it, actually. Any other ideas about relational and non-relational databases? It doesn't have to be a database context, just the word.
So I think it's what is non-relational? It's one, let's say, object contains all the information it needs to be something, rather than one object fetching other information from somewhere else.
Mm-hmm.
It just has everything. I don't know the case.
Yeah. That's actually true. That's also a good way to look at it. Unfortunately, it's... please.
Basically, SQL database are table-based SQL, so you can have your row and your seed. But Mongo database is JSON. So if you want to see it, you should use some code and also some, I don't know, something to see it better. So it's JSON and table based.
Yeah, this is one of the biggest benefits of MongoDB, that it can work with JSON, but it doesn't only work with JSON. You don't even have to use JSON to interact with MongoDB. So it's not actually, it's one of the most prominent features of MongoDB, but it's not the discriminator between relational and non-relational databases. Because, for example, PostgreSQL can also store JSON data, and you can also query based on that JSON data. Which is obviously a relational database. So unfortunately, this is like I told you earlier, the naming things is hard, right? This is a very unfortunate name. When you think about the name relational, you think that, there are two distinct things, entities, and there is a certain relation between them. And this database is very easy in figuring out the details, figuring out the relations and their communication. Like a person and a class. A person is a student in a class, right? A class consists of 30 people, for example. A student has homeworks. Homework has grades. These are different entities, and then they have some relations in between. Like a person has multiple homeworks, but probably each homework has a single grade, right? And so the idea was to basically model these entities and their relations in a data structure, and Previously, people were using flat JSON or flat text files, the way we did in the first few lectures. We were directly writing to disk and reading from disk. And there was no clear, structured way to indicate their relationship. Which file has which data, which file is related to what other file. We had a file for person, for example, and you created individual files for every single entity that you had, model that you had. And then they came up with the idea of a database that, it stores all this meta information for you in something called tables. A person is a table, a student is a table, grades are tables, or homeworks are tables. And then you have certain relations in between them, and it's easy to basically build on these relations, because almost always we are interested in a combination of data. When we fetch a student, for example, we want to see their grades as a summary, and all of that data. Individually, grades don't mean anything. They mean a lot in a student's resume, or what do you call it? The fact sheet of students, with A's and B's and F's.
Gradebook. No.
Gradebook. No, transcript. The academic transcript, yeah. So grades mean a lot in the academic transcript, but even then it's, for example, accumulated, right? If you had 3 exams for a course and you scored 10 or 20 out of 100 every time, you're destined to get an F. The raw data is that your grades are there with 10s, 20, and 30, whatever, but the transcript shows that you got an F. So there has to be a transformation from that raw data to that transcript. And we do this by writing queries. Hence, for writing queries, we need a language. That's why it's called structured query language, SQL. And it's basically a way to interact with databases. It's a standard, and again, a lot of people love it, but I hate it. I think it's very hard to understand, especially for beginners. I think I'm writing SQL queries for almost 20 years now. I still hate it. And it's still very, very confusing for me to do complex queries in SQL. Like, I just can't. It's just not a natural way of doing stuff. But these guys are called relational databases. So if you have a very different approach that you want to market, what can you do? You cannot market it with the same name. You have to oppose people, right? Hence, they came up with the name non-relational, which is actually not true, because you basically still have all the relations in your database. Like, you still have people. Hello, come in. You still have people. You still have their grades, the classes, and everything. It's just there are different mechanisms of relating them. And it's more that, the database is less opinionated in those relations. And you may have to write some code yourself. If you remember, we had to do the population of a person's friends. Do you remember that? We were storing friends of each people, so people could make friends in the API. But we were only storing the IDs, and then we had to specifically write populate and then give the friends the field which it will populate, so that we could fetch all the friend information. That was a manual step that we had to do, but it doesn't mean that our data is not relational, right? People are still related to other people, and they're still friends, and we still keep them in our documents. So naming is hard, and don't take the names for granted. A lot of people do. Like, you'll see hundreds of posts online that describes why MongoDB is not a relational database, but that's unfortunately not true. When it comes to NoSQL, that's true. It doesn't support SQL. It has its own query mechanisms that I will show in a minute, that we will do today, which is mostly based on JSON. That's why it maps very well with web projects. From a front end, you call axios.post or .put, and you send a JSON object. and MongoDB speaks JSON natively, so that it directly understands it and records it to the database, whereas it's not the case for other databases, and I'm gonna give a more concrete example in a second. All right, so did everybody clone the repo? What about others? No? Why not?
Because then I have to divide my attention.
Okay, perfect.
Are we supposed to do node SRC fixture?
Sorry?
Node, like a bit down. Source fixture.
Yeah, but you don't have to do it. Like I will tell you, we can do it together. It throws an error. It may be that you don't have MongoDB running. If that's the case, check that. Yeah, and then we still have some instructors here who will help you out. All right, this was a very, very fast entry to MongoDB. The thing that you have to keep in mind is that it's very, it works very well with web projects. Anything, if you work with JSON, it's a very natural database choice for you. And I'm going to give an example and show how it natively fits that. For today's exercise, we will generate some data from scratch. Actually, I did, but as an in-class experience, you'll also do that. And we will basically insert that data into our database, and then we will work with that. So if you go to the repository, there is a file called data.json. This is the file that we're going to use today. It contains 100 records that I generated on the internet. I'm going to show you. It basically, it's kind of like an emergency management system. Each record is an emergency call, let's say. Okay, so we call them cases. They have a case ID. They have a type, like somebody obstructs my parking, so please come and pull this car away. It has an address where that incident happened. State, city, street, house number. These are all random stuff. It has 2 dates. When was the case open? And when was it updated? So 2 different date information. It has a description that's random text. It has a person who opened this case. So first name, last name, and age, and the gender. It has phone numbers attached to that, and home number and a fax number in case we want to call them back. And it has a location. Where did this thing happen? Question? Okay. Ömür? It has a location. It has a coordinate for when, where did this happen. And these are all generated automatically. We have 100 records here, and I will later, on the second part, ask you to do a similar thing. How we do that is here in the template.js file. We have a template for this data, and above you see the URL, next.jsongenerator.com. That's what we're going to use, and that's what I use to generate this data. You basically pass in a template, and it just creates however many records you want. I said the maximum is 100. I said I want 100 records, and it has some built-in functions. It can give you the name of a state. It can give you the name of a city, and a street number and a house number. And it can also choose between something like an enum, predefined text, and that's actually what we use for the gender. So we have male, female, and other. So every person is assigned a random gender from this pool, and it can also generate realistically looking phone numbers and a location. So this is almost like our model definition in Mongoose if you look at it. We have the fields and we define what they should look like. And this is how you generate data. This is really important if you want to create your own randomly generated data for your own web projects. Because most of the time, if you're doing front-end programming, for example, the API will not be there. The backend will not be ready, which means you have to work with some sort of data. You have to have some realistic data for your application to show on your application. Where do you get that data? You generate it from here. It also gives you photographs and placeholder images, so you can also use that. All right, the second thing that I'm going to show here is the model, the case model. This is very simple. This is basically what we did before as well. We had a very simple model called people or person, and this is a little bit more advanced version. So we have the case ID, we have the type, we have the address. Address on its own is a different entity. Actually, if you look at it, it's a different object. Like each case has an address, and an address has a state, a city, a street, and a house number, right? A model actually doesn't have a state. A case doesn't have a state. A case has an address. An address has state, right? You know, we just opened that and updated our dates. Age is a number, gender is an enum. Phone numbers, they are unfortunately strings because they also include spaces and parentheses. And location is again an array of numbers, for example, the coordinates. This is how you define a Mongoose model. This has nothing to do with MongoDB, actually, because MongoDB doesn't know anything about models or a structure. It accepts whatever JSON you give to it. Any JSON, any valid JSON you can insert into MongoDB and you can query it. And obviously it's a little bit hard to work with. You know, we kind of like structures as developers because we have classes, right? We do object-oriented programming and we have classes in our code that have very rigid fields and behavior and data. This is basically what it is. This is us enforcing that structure onto the database. And this is pretty much common. This is called ODM, Object Data Mapper. So we work with objects in our runtime. Like we have cases and they have addresses and stuff. But then these are stored as documents in MongoDB. Actually, I hope I can show an example to you. So here is MongoHub, a tool that I use for querying Mongo data. This is basically the same data that I have in the database. And each one of these things is a document here that starts with an ID, it has an address, it has a requester, location, phone number, whatever. This is a document. It's called a document because it contains everything that I need with respect to that piece of information. You know, I have the address of the case here as well. I have the requester of the case here as well. I don't have to go to another table and fetch that information from that table. It's basically stored here. That's why this is called a document. And we have Mongoose on top, which is called, again, an object document mapper, because it maps this document to an actual object in JavaScript that you can interact with. And in other databases, if you are working with relational databases, what would be the name? They don't have documents. They have dedicated tables for everything. Like if it's a case, you have a case table. If it's an address, you have an address table. If it's a requester, you have a requester table. And then you join them together. That's a very important keyword in relational databases. But the question is, if we have object document mappers for MongoDB, which works with documents, what would we have for relational databases? What is the counterpart? Yeah, we have tables, but there we have something like a Mongoose on top of the database that maps our objects to the data that's stored in the database.
Or
Yes, that's called ORM. What is R there?
Are relational?
Yeah. So normally you work with ORMs for regular databases. For relational databases, it's object relational mapping. It maps the data in your database to the objects in your application. Because again, in your application, you want a case object. In your application, you want a single object that represents every piece of information about that case. But in your relational database, there is no way to store the address in the case. You have to have a separate table, separate address table, and then you will relate it to the case table. You have to have a location table, and then you will relate it to the case table again. And this is why it's called relational, because every relation is basically explicit, and we have implicit relations here. They just contain each other. We don't really deal with, individual addresses. We just don't need that.
And the containers are JSONs?
Sorry?
The containers
Yeah.
are JSONs?
Yeah. You can insert it as JSON. You don't have to, but it's a good way. Yeah.
Container can be JSON.
Yeah.
Anything else.
Yeah. All right. So let's go back to our model. There's one more thing that I want to show you, and it's the first advanced construct that I'm going to talk about today, and it's geolocation and geographical queries. This is actually what Arati used in her graduation project in the first lecture. Basically, we store the location information here, and we want to be able to any point that I give. Because let's say we are the emergency center, and we want to show all of these things on a map, right? And with map, I work with coordinates, so I can display these on the map. But what if I want to see, when I zoom in, I want to see the cases that are around me or that are around a particular area? I use geoqueries, so geographical queries. And the way to do that is by first indexing the data. I index the location here, the location field, as a spherical mapping, because the Earth is kind of a sphere, right? So the locations are latitude and longitude. They are mapped onto this globe with the spherical projection. I don't know the actual name of the projection, but later when I want to do a geoquery, I'm going to give it a center point, and I'm going to give it a distance that I want to look for. For example, I'm going to add a pin on my map and say, give me everything that's within 10 kilometers of this pin. And that's actually very straightforward, very simple with MongoDB, but I need to first index my data. And then my question comes, what is indexing data? Why do we need indexing? And again, raise your hands and tell me. Think about the word index, where you heard it before. Why do you normally use indexes? Yeah. Please. They order one by one?
Yeah, when you're ordering, you order something, then there's an index, it's easy to put them.
When you have an index, it's easy to put stuff into places because you know where that should go, right? A very trivial example is a phone book. Like even the digital phone books on iOS and Android, they have a strip of letters to the right, right? So you can swipe your finger alongside and you can directly go to specific letters. That's called an index. An index is something, or table of contents, is something that gives you shortcuts to important pieces of information within your data. So if you have an index, it's very easy for you to access what piece of data that you're looking for. You can index any field, and for example, you can index the type, okay? And what kind of types that we have? 1, 2, 3, 4, 5, 6, 7, 8, 10, and 11. So we have 11 different types, case types. And what you can do basically is index your data by these types. So whenever you're searching for, cases that are open manhole cover, if you have an index on this type field, it's very easy to find the records that you're looking for, right? You basically have an entry point. You know where your records are. Think of it like the phone book. Like you put your finger on P, you open that page, and everything that starts with P is listed there. You don't have to search for it in any other page if you want to find records that starts with P. It's basically the same logic here. That's why we're using indexes. You can index any field again, and indexing it makes it very fast to query data. Whether it's by type, whether it's by address, and whether it's by location. So obviously, this is a typical longitude, 122 point something. How do you actually index it? They have very complicated algorithms. Obviously, it's not by every 0.1 increment here, or like 0.00001 increment. They have very complex algorithms for indexing this data. But in the end, if you index your location, if you index your database records based on this location data, then you're able to do location queries. Then you're able to do, give me all the records that are near this point. It can also do really complicated stuff with polygons. So for example, you can draw the map of Berlin as a polygon, enter it into your database as a record, as a document, and then you can query based on that map. Am I inside Berlin area or outside? This is, if you think of it, this is very useful. For example, think of Drive Now or Car2Go. They have certain areas on the city where you cannot park, where you cannot leave your car. You cannot take your car and go out of Berlin and park it there. How do they do it? They do it by using structures that are similar to this. They have a polygon map of the areas that you can leave your car, or the areas that you can't leave your car. And whenever you want to leave your car, they just do a geographical query and say, am I intersecting, that's also a good keyword, am I intersecting any, forbidden areas to leave my car? Am I in a green area that I can leave my car? And if the result is yes, then you can end your booking and your rental. And it also has to always happen with indexing. Otherwise, there's no way to know whether you're in a certain polygon or not. Is it clear a little bit why we use indexing? The question could arise, if we can index data and if it's very fast to find any data when we index it, why don't we index everything? Why don't we index every field? And why does it still take me 1 second, 2 seconds when I load my posts on Facebook, for example, or when I go to Twitter, or when I check my messages? The reason is basically you cannot index every field. Technically you can, but that requires a lot of RAM and a lot of hard disk space, because the indexes are kept in RAM. It's why it's so fast. And the actual records are kept in the hard disk, so the index actually points to places in the hard disk where you can fetch that information from. So, your average server would have, your database would have 16 gigabytes of RAM, 64 gigabytes of RAM, maybe if you're very serious, 128 gigabytes of RAM. And that is the amount of index that you can store. And of course, every field creates an index that are very, very large, and it grows really bad. Like, it may be okay when you have 100 records, when you have 1,000 records, but when you have 100 records, 100 million records, then you have to be very careful with your indexes. You cannot index everything. You have to pick the best field that will give you the best performance. So it's actually, please.
Also, if you're thinking that aggregate, I can have like infinite amount of RAM. These indexes are recalculated every time a new data is inserted. So in case you have like infinite amount of RAM, then your insert operation will be a lot slower if you index every attribute there.
Yeah. So for example, you're indexing type. Okay. You have one single index on one single field. That's very modest. That's very good of you. Thank you for taking care of the environment, because more indexes means you're burning more electricity, which means you're damaging the environment actually. But apart from that, what happens? How do you update that index? Like, what happens when you have a new record that has to go to a certain place in the database? You have to update the index. You have to, most of the time, recalculate it from scratch, because it may be touching multiple points. And frankly, in real life, you have more than one index anyway. So there is no way to know how it will affect the actual structure of the indexes. There are some optimizations, but to keep it brief, let's say that every time you insert data, you have to update your indexes, which means it's okay if you have one index. It's not okay if you have 15 different indexes, because it takes a lot of time. So think about a write-heavy application. Okay, write-heavy means that we do a lot of writes. We write a lot frequently to the database than we read data from. Think about an application that reads sensor data, for example. And every second it reads the temperature and it stores it in the database. Every second there will be a new record from one sensor. If you have 100,000 sensors, you basically cannot cope with the load of it. So what do you do there? You sometimes don't index the data, because you cannot afford that. You cannot afford recalculating the indexes every time you insert a piece of temperature reading to the database. You have some summary tables, summary collections that you read from. So this is proper engineering. This takes a lot of time to learn and to master, but this is a skill to know which data to index for faster queries, keeping the constraints in mind. You have limited RAM, you have limited hard disk, and you have limited energy, real like electricity. You cannot compute the index every time you record something to the database. So you have to be very careful on what you index.
If the data is not indexed, does it get lost?
Sorry?
If the data is not indexed.
If the data is not indexed, does it get lost? No, it does not. But it's just slow to find out where that data is. Because if you don't have an index, think of the phone book. If you don't know where the letters are, how do you find your contact? If there is no order, especially, that is the biggest problem. How do you find your contact? You have to go one by one on each page, right? That's actually the problem with databases. When you are not indexing your data, most of the time, again, of course, there are a lot of optimizations around this, but most of the time, especially with complex queries, it reads every single record and checks if they match the criteria. So they're basically going over them one by one, over all the records. There is no other way to do it. So that's why you want to index your data, because you also cannot afford to read 100 million records each time you want to find a single record. It's like searching for a needle in a haystack, and it's exactly, literally like that. Like you have as many hays in the haystack and you're searching for that single one. How do you do that without an index? You cannot. That's why it's very important. And that's also why indexes on geolocation is mandatory. You have to index your location data if you want to query it. You cannot query location data without indexing it, because it just doesn't make sense. There is no, it's not feasible to compute it without an index. Of course they can do it, but it's just not feasible. So please index your data. All right, so we talked about this before, but we also have this unique identifier here. If you remember, it makes sure that the case IDs are unique, and you cannot create a new case ID with that same ID. You cannot create a new case with that same case ID. All right, so make sure your MongoDB is running, and we'll go to the terminal. Let me delete my database. You go to the terminal and write node source fixture.js. What this does is very, very simple. It's basically like 3 lines. It reads the JSON, the data that I generated, and just does case model.create. It's as simple as this. It just creates 100 records. Run it, and it says done, 100 records inserted. If you have RoboMongo or MongoHub, you can directly see it as a new database that it inserted all the records for you. Abstracted parking was the first one. Yeah.
How are you supposed to find that exactly? Because for me it says record inserted, but I don't know where to find them.
It's okay. If you have RoboMongo, it's very easy. It's very straightforward. If you don't, it's all right. That's not even optional. It's just a luxury. Because the idea is that we interact with the data by queries and not visually by seeing it. All right. If all of you got this insert message, it's there. One way to check it, type Mongo and use, what is the name? WTM5 and db dot, is it cases or case? Cases, find, and you'll get 10 records. So use WTM5. It switches to the WTM5 database that I created. And db.cases.find, it's JavaScript. This is basically running JavaScript. db.cases.find gives you 10 records in JSON. But it's not storing the data in JSON, of course. It has its own format called BSON, binary something, object notation. I don't know what S is. The S is in JSON is JavaScript object notation. I don't know what the S is in BSON. All right. Who is with me?
Is this a jQuery or is this just JavaScript?
It's just JavaScript. jQuery only works on the front end, and it's an abomination. It shouldn't have even happened at all. All right. Now, question, please.
I would wonder if you use pretty there.
Sorry?
I would wonder if you use pretty in your console, what would happen.
If I use pretty?
Yeah.
I don't know.
Because it makes it more beautiful. So,
okay, yeah, you're right. In fact, let me try something. But this gives me cursor. All right, yeah. Here you go. So when you can directly convert it to a JavaScript array, and this is data that we had in our JSON file. And while we're at it, you can convert it to an array, which means you can use all the array operators there. So let's get the name of the requesters. Oh, it's first name. So db cases find to array map. I was working with database records with cases, I fetched all of them by typing find. I converted it to a JavaScript array, and then I map it to a different array. I get the first name of the requesters of each case, and I will make a new array for that. You don't have to type this; it's just an extra exercise. But basically, this is how you can query MongoDB on the command line.
So I'm just wondering, how can you use JavaScript to connect anything with
Because they are very nice people, and they wrote a layer on top that understands JavaScript, and that works with JavaScript. So that's why I really like MongoDB, and I don't like other platforms and databases, because they're not built for developers. This thing is built for you. This thing is for you to play with. The others are built for data, but you know, in the end we suffer because it's built for machines, not for us. This thing is mostly built for us, and then machines have to adapt to this, and it's actually very easy. I mean, MongoDB just works. And also, it scales a lot better than relational databases. It's out of our topic for today, but scaling databases is a huge issue. Think that you are Facebook. How can you store 2 billion people's data, their posts every day, every second, their likes and their comments? They have their own databases. They started with MySQL, and then they wrote custom patches on top to make sure that it still works and to make sure that it scales, but it's very, very hard. It's a lot simpler with databases like MongoDB, mostly because they are non-relational. Like, mostly because you don't have to have this 130 different tables to create just one single document.
Can you transfer relational database to non-relational?
Yes.
By mapping?
It's very convoluted. You have to find a matching model. You can mimic everything that you do with relational databases here, but then MongoDB would also be really hard to scale. The idea is not to create different collections. You know, like I could create an address model, a case model and an address model, and I could create a requester and do populate, for example. But that's not how MongoDB works. That's not how it's designed or how it's supposed to work. That's why we're calling this NoSQL or non-relational database. We don't do that. If this is a document, if this is a single thing that I'm interested in, then I create a single collection for it and put all my data into that.
Is this a graph database?
Sorry?
Is this a graph database?
Is this a what?
The MongoDB. The structure is like a graph database.
Graph database? No. But MongoDB allows you to do graph lookups, graph queries. But, you know, for example, Neo4j is a graph database. And that's also identified as a NoSQL database, because that also doesn't support SQL queries, and it's not interested in type of relations that those databases are interested. It's interested in real, actual relations. And you create records by creating the relation first. It's you know, a different discussion, but it was one of the shortcomings of MongoDB. I mean, it's also shortcomings of every major database. They don't support graph queries that well because they're not graph databases. But at least MongoDB implemented some structure, some query capabilities so that you can do different kinds of lookups. You can do lookups from directly another collection. You can kind of index them together, different collections, and do a graph lookup and stuff. But it's still not as native as Neo4j, for example. The idea is, once you go this route, the possibilities are endless. You can use Neo4j for graph databases and for your graph needs. You can use a NoSQL database for mostly anything else. And if you're really interested into transactions like monetary transactions and financial records where you have to be very specific about the structure and the validity of the data, then you can use relational databases. So the idea is one tool will not solve all of your problems, and you have to use the right tool for the job. I'm not doing financial transactions, and even if I do them, I like to write my own transaction handling mechanism within code and not in the database. That's why I mostly use MongoDB. But that's a very sane choice to use relational databases for financial data, where you have to basically calculate every cent and you cannot make any mistake about it. Whereas who cares if you just deleted one comment from a Facebook post? It's not that critical. People are not losing money because of that.
All of the context questions. Blockchain.
Blockchain.
What kind of database they are?
It's not a database.
It's not a
But you can simulate a blockchain with any type of database.
blockchain can simulate any kind of.
The data structure of the blockchain, not the calculations, but yeah. Because it's basically a chain. It's like Git commits. You can even do blockchain on Git. Every Git repository is a blockchain, minus the calculations. Or not even that. It already does the calculations, right? Every Git commit has a unique ID that's also a hash. So unfortunately, let's not start discussing blockchain. Unfortunately, I have.
That's why I said automatic.
I hate it. I just hate it. It's so misunderstood. It will never solve any of the problems people claim it solves.
Yeah.
It will never do that, and it will never scale. But it's a huge hype and a speculation tool. All right. I discovered that we didn't take a break last week. It's not a problem. I can still go on talking for hours. But if you want, we can take like 5 to 10 minutes break and then come back and start talking about real queries that we can build with MongoDB. Okay? All right, 10 minutes break. So, please open index.js. This is where we'll write our code. Let's first run this. Go to the debug menu and click this button. Start debugging.
In which folder is it? Index.js.
Yeah.
So many folders, but I don't know which one.
It's under SRC.
Okay.
Oh, I forgot this. All right, you need to remove line 1, the first line that says console table. You should delete that. Okay. If you click this button, it gives you an array with 100 items. Who is with me? Are you able to run it? If not, please call an instructor. We have Anya and Ömer. Anyone? Need help? Okay. Make sure you open your directory in Visual Studio Code and no other. Maybe you're opening a parent directory. Make sure to open only the project folder.
That's on the project folder, but when I do the debug, it just gives me errors.
Yeah, one step I may have missed. Did you do npm install?
I should see, but it still says tell me that dark sky. I don't know why. It's like the dark sky.
All right. Bless you. Let's do one more thing. that is the breakpoint. I stopped this running code. I put a breakpoint on line 7 by just clicking to the right, because I want to stop execution and inspect stuff in real time. I'm not okay with this log. I want to do some operations in real time. So I started again. I guess it's function F5 or something. Yeah, it's F5 basically.
So, what was the command to do that?
Do what?
We are doing now just in start?
No, I just clicked here on the debug menu. Here.
And in the console?
I go to debug console and I see the output. If you get custom inspection function on objects via blah blah is deprecated, that's fine. That's not a real issue. Okay. Now, I have this breakpoint. I run my code. It stops on that breakpoint. So now I basically have insight to what every variable keeps in themselves. So I have the record here, and I can go into their details, the document here, the address, state, Palau, street, whatever. It all works, right? All I did was I said await. Why do I use await here? On line 6, why do I use await? Come on. This is your last chance.
On a synchronous operation, so like you wait for the thing to be done and then you do the operation?
Yes, because it's an asynchronous operation. We're doing a call to the database, which is living in a different server. It's a network operation. So I don't want the execution to continue before coming up with the results. I'm waiting for the results. That's why it's called await. Case model.find is the way to get all the records, right? And then I just log them. The same thing we can do here. For example, I can map it to get the first names. It's basically the same thing that I did at the end of the last lecture. Let's run it again. And you see the arrays, the names here. The first names of everybody. So I did rec.map, and for each record, give me the first name of the requester of each record. Right? But obviously, this is not a database query. The database query was fetching everybody and everything, and then I manually got the first name. If you think of it, I transferred all the information of all 100 cases from the database to my application, right? And this is costly. This is kilobytes that you're downloading, but you're only interested in the first names. So there should be another way of fetching this information from the database, right? Does it make sense? So that I only get the first names and not anything else. Let's go back to record here. We do that by chaining other functions to this find function. The find returns a query, and there are tons of different operations that you can do on it. One is called select. Select lets us choose individual fields that we want to have. And let's first choose the requester field. Okay? I run this again. I wrote select, and in parentheses I wrote requester. Now, when you see the detail, it only has the requester. Every object has only the requester. There is no location in it. See, there is no location. This looks a little bit convoluted, right? This doesn't look good here. I have the model, internal cache, blah, blah, etc. A lot of other stuff that's not related to my document. Proto, right? This is the case because we were talking about object document mappers, right? MongoDB maps that document to an object. Therefore, it creates a kind of a container that holds your data, and that's why it stores your original data in a field called _document, but then it has additional fields on top that are designed for its operation. Now, Mongoose has to wrap every record that it fetches from the database in order to understand it, in order to make assumptions about it, in order to check the types of the data. So, for example, if you go to the case model, we say it should be a string, right? How does this know that it should be a string? Or when does this enforce that it should be a string? It does this by wrapping the original data with another structure, but this means it spends precious CPU time, precious clock cycles wrapping every data. Maybe I'm not interested in Mongoose functionality at all. I'm just interested in the actual data that's in the database. So I want to save precious computational resources. And this is really important in a production database. You always do this. If you don't need Mongoose, you never use Mongoose. And the way to do that is to add .lean at the end of my query. This gives me lean documents. This tells Mongoose that I'm not interested in your operations. Just give me the raw data records that I need, and I'm going to operate on them manually. So don't wrap anything, don't try to do any validation, don't enforce anything, don't try to populate anything. Just give me the raw data. Okay? Now, look here in the watch section. This is, come on. Anyway, this is how it currently looks. Like this record is an array of 100, and every item is this model, internal cache, is new, false, init, and stuff. Case ID description, errors, these are undefined. So this is how it is right now, and I put the lean here. Let me rerun this. I run it from scratch. Now when you look at the array, it's very, very straightforward. Now every record only holds the requester. There is no is new, internal cache, etc. Because these are regular JavaScript objects right now. So it converted the MongoDB document to regular JavaScript objects without messing up with the internal structure, without wrapping it, which is, saves me time and money, actually. So, okay, it's a little bit easier, but you see every record has the ID, _ID, that's there for sure, that's always there. It defines the identity of the record. And then every record has this requester field that I selected here. Requester, age, first name, gender, last name, okay? I think I can remove that ID even from these documents by doing minus. That means I don't want that field, _ID. And I run this again, and see, you just have the requester. There is no more ID in these objects. We have the requester. Okay, we were only interested in the first names, so let's just get the first names, okay? How would I do that? With this structure. Yes, of course. Instead of the requester, I want requester.firstname. I run it again. you see now the requester only has the first name. It doesn't have any other fields. It doesn't have the age and stuff. Okay? This is very important because I optimized the data that I'm fetching from the database. I told the database that I'm not interested in any other field other than the first name of every record. So give me the first names of each record. So it saved me a lot of network transfer, which is really important when you're running at a large scale. You had a question?
Yeah, do we need to keep the minus ID then in those cases if we remove?
Yes. If you don't put it, it always gives you the ID.
But is it best then to just remove stuff or just to be what you want to see, like if you have more or less the same language?
Yeah, like if you don't need the ID, don't fetch it. Don't fetch anything that you don't need.
The same amount of stuff like to fetch or to just not to see. Which one is best? Is it better to just add requester.firstName, requester.that?
Ah, okay. Just depends on your preference. Doesn't really matter. Alright, so this is how we select data. This is how we, fetch every record and select some pieces of information about that. Now, it's simpler for me to write this like this, so that you can also read it better, each line. Now I want to do a real query. I didn't really do any queries until now. Let me fetch people, the first names of people that are... Sorry?
Or in a specific location.
I will do that. I'll come to that. But first, a little bit simpler query. Let's first filter by age. 24, I don't know. Give me the first names of people who are 24 years old. Of course, this is requester.age. Okay? Let's run this. Oh, there are only 2 people who are 24. Copeland and Ethel. How do you know they are 24 years old? Let's include their age in this select call. And run it again. Here, age 24, requester, age 24. Apparently there are no other people. But this is how I impose a certain criteria that I look. Give me people who are at the age of 24, and then fetch the first names of those people. Okay? Now, how do I do when I want a range? I want people who are aged between 24 and 30, their first names. How do I do that?
Maybe we need 2 things.
I need 2 things. Like this. This would fetch.
No.
Yeah, this would fetch.
Just a tree for that tree.
Sorry?
It's going to just to.
Okay, I'm going to show you. Our criteria is that people with ages who are like ages that are greater than 24 and less than 30. And we're going to use that functionality. We have certain modifiers in MongoDB in its own query language, which is JSON. We can do this. Requester age is greater than 24, less than 30.
That's going to give us 25 to 29.
Let's see what it gives us. Oh! Okay. 29. How many people we have? We have 11 people. 28. 29. Yes. Basically anything that's greater than 24 and less than 30, which is by ages 25 to 29. Of course, we can change these, and even you can also do less than or equal to, or
Greater than equal to,
greater than or equal to.
then it's going to be, yeah.
Now you have 14 people, and see, this person has 30 for their age. So this is very simple again, how I query based on ranges. Okay? The ranges also work with dates. So if you're looking for a specific date, you can use less than or greater than to find records that are, you know, that are earlier or later than the date that you give. So there's one thing that I want to do now, which is sorting these records by age, because this is currently almost random. You know, it starts with age 29, age 24. I want to have records that, you know, start with the lowest age possible and then going up to 30. How would I do that? It will be there. How do I do that? You know, by looking at the structure, can you imagine a way for me to do it?
Is there a sort?
Huh?
Is there a sort function?
Yes, there is a sort function. Exactly. So you write sort, and then you give it what you want to sort it by. Like age. Okay. I run it again. And age 29, 25, 28, didn't work. Why? Because the field name is wrong. Huh?
Can you order ascending?
Yes. So first let's look at this. We have requester, age 24, 24, 25, 26, and 28, and the last one is 30. Okay? This is an ascending order. It goes up. The first record is the record with the lowest age. I want to have a descending order. How I do that is very simple, by adding a minus. That's good. And now it starts from 30 and goes down to 24. This is not exactly how it's done in MongoDB. This is a structure that Mongoose provides you. This minus requester age and stuff. But also in MongoDB, it's also very straightforward. You do it just like this. Requester age minus 1. If you get 1, it sorts in an ascending manner. If you get minus 1, it sorts in a descending manner.
But sometimes in the front end we have a choice, like to just click
Yeah.
the button, then how that thing is sorted out, like either in descending or ascending.
Yeah.
The buttons are there.
So think of it like this. I get a parameter called order, okay? If order is ascending, I have nothing. If not, which is descending, I have a minus, okay? And then, in my sort function, I do order prefix. So, if I pass in ascending here, and run this, you will see it starts from 24 and goes up to 30. If I give it anything else, like descending, it starts from 30 to 24. So this is basically how you would do it from the front end. The front end with a Axios request, with a post request, tells whether they want it in an ascending or descending manner. And on your backend code, you have a function that gives you these results. You just make it parametric. And it's, this is a very, very simple way of doing it. I wouldn't write it like this, probably in production code, but you can. If I were preparing for a challenge, or if I were doing a coding challenge for a position, for example, I would definitely write it like this, because it just works. It's simple, right? Let's go back.
And why you wouldn't use it in production? Because it's not.
Because I think it's very. It could be dangerous to include certain, parameters in your, for example, sort parameters. It's not very dangerous for sorting, but for other stuff, like for selecting fields, if you had a variable here, and if somebody could pass in password, they could get your password, kind of. So I would require a little bit more structure around that, and to prevent that. I don't really like string manipulation and queries based on string manipulation. This is a sickness that is reminiscent from SQL. When people are writing SQL queries, they just pass in whatever string they get from the front end, from the end user, and when you pass in admin equals true, kind of you're an admin in the database. So, or you can delete every record in the database. This is called SQL injection. So it's never a good idea to directly pass in strings to your database that are, manipulated by an external party. So there are other ways of doing this. Basically, you do it like this. The record is done a query. You don't await it. And then you say, if order equals ascending, rec equals rec.sort something, else it's rec equals rec.sort minus something. And then you do await rec, kind of. This is, this has more structure. There is no sorting outside your control, and you exactly define what you need to sort. Because, people could mess with code. It doesn't have to be an external party. Your developers also mess with code, and you have to prevent them.
How this will be presented in the front end? Will it be 2 buttons or?
Depends. As you said, most tables have a single button. When you click, it sorts. It toggles between ascending and descending order. So every time you click it, it makes a new request to the backend, fetches new data, and shows them.
This has something to do with global variables?
No. Not at all. There's another way of writing this query, which is a little bit simpler maybe, but I couldn't get used to it still. Instead of the find, we will break this find into multiple arguments, multiple function calls. The goal is to get rid of this, this JSON structure. So we do await.case model. We say where and requester.age. Okay. And then we have GTE here, greater than 24, less than 30. Okay? And then when you do your select and sort, it gives you the same records. So it's two different ways of doing queries. I like the flexibility of this JSON object approach, but you know, people have different preferences. Yeah, of course. Where requester age is greater than 24 or less than 30, and select these fields and sort them and fetch me the results. It's really simple to read, right? Question?
Yeah, but maybe it is too fast or too fast. So like if we want to give choice to the user at the front end, to give the age.
Again, you do a parameter like mean age, max age,
Okay.
and then you do mean age and max age. Please.
I was wondering also, like, if you have like several parameters, like if you want like where's the requester age is this one, and where's the location or where's the country is this one, or where's the location is this one and this one. How do you do that?
Let's look at it. So this is how you do it. Parametric. You basically take in function parameters and pass them to your query. And how you do that, you can have, you know, as less than or greater than, you also have an or operator.
But with the where, how do you do this?
With the where, you cannot do it.
Okay, so you have to do it this
Yeah.
way. And you can do also and.
Yeah. But you see, this is getting really complicated already. And then you can pass in a different query. Oh. What's going on here? Okay, yeah. Yes. So, for example, people from age of 15 to 20 and 20 to 24, or 20 to 24. And it didn't work, of course. Why should it? Oh, let's remove these. I'm pretty sure this still won't work, but... Oh, it did! You cannot use where it find. You have to choose one or the other. But see, this person is 15 years old now. This person is also 15, so 17, so on and so forth. This is how you do OR queries. If you do AND here, what happens?
You have both. Or you
You have 0. Why?
Because person can't be having age 15, 24, 38.
Yeah.
So that you can't put it.
Yeah, there is no number between 15 and 20 that is also between 24 and 30. So it just won't work, right? Cool.
In this case.
Yeah.
Maybe some other cases.
Yeah, of course. Definitely. All right. One more. Let's look at the data. We had these types, right? Obstructed parking, open manhole cover. All right, let's look for the issues that are open manhole cover. Type open manhole cover, and then don't select any field. Sort by the age. So here you go. We have 9 different cases that are open manhole cover. These are all the cases with that open manhole cover type. Okay. Now,
Is the file is case sensitive? So for instance, if
yes, it is. So the next question is, what happens if I also want to get another type? Like I want to fetch all the open manhole cover cases plus all the uncollected garbage cases. Okay?
Do you have an end and or function, or do you just execute find and then find?
For this, you mean?
Yeah.
For this, we have something called in, a new operator called in, and we will pass in an array. So we'll say that I want to find types, okay, that are in this array. So I pass in an array of the values that I expect. So find me every record with the type which is in this array. Which is nice. Very simple. And you get 12. Previously we had 9, now we have 12. So some of them have a different type. See, this one is uncollected garbage. Okay? This is another operator that we use. Greater than, less than, in. These are different operators that, that we can make use. And the best thing is you're still writing JavaScript, right? This is still JavaScript. Like this object, this array, you don't have to learn another language. You don't have to learn a new syntax that is radically different than what you already know. So only by using JavaScript you can execute these queries and build your database. Is everybody with me?
Yes.
Then let's look at the geolocation thing. How do we find records that are near some point? Let's look at some example locations here. Like the coordinates are here, minus 122, 38, kind of there. It's around that. And already if you also look at the template, this is basically how we set it up. The coordinates are random numbers between this, and 38.6 and 37.8. So I just came up with random numbers for the coordinates. I don't know how big an area this spans. I guess it's around 40, 50 kilometers. But we're gonna run some queries around that. All right. So let's start from scratch. Let's find every record. Huh? Coordinates. It first starts with location. But this is a special object. This is a special syntax. This is called GeoJSON. Basically, it's an object that shows whether this is a point on the map, or it's a polygon, or a line, or a polyline, which have multiple points. This one's a point, and it has 2 coordinates. But it could also be a polygon with multiple points, and then it would be an area. It would cover an area. It could be a polyline, and that could be a route. To, you route from A to B, point A to point B, that's a polyline with multiple branches. So this is a special construct. So we didn't come up with the name coordinates here. This is just standard, industry standard. We just said, the field is called location. It's actually easier to use where on this one. Let's say where location, okay, is what? What could be the keyword here? Give me all the items where their location is, what is the word? I'm doing a geoquery. From could be, but between or
Near.
near, yes. Ah. I don't know what's happening. Okay. Where location is near a certain point, and that's, so we give it a center point. Okay? We said, give me all the cases whose locations are near this center point. And this is also the same structure, type point and coordinates is an array. So minus 122, 38, for example. And is this enough for fetching the data? A radius, because this is a point, right? Like we kind of are interested in a circle. This is the center point of that circle. You need a distance, a radius, so that you can cover an area, and it's called by max distance. And in this case, it's in meters. When I'm using this format of points, this goes in meters. So it's like 10 kilometers. Give me everything that's within 10 kilometers range. I restart this and didn't work. Where is not defined because I'm missing a point here. Yes, I have 5 objects that are within that radius, within 10 kilometers of this point. 5 different cases.
The value of coordinates, minus 122, 3, where is that?
Where is that? I don't know. I don't know. I guess it's in the States, but you can put it on Google Maps and see where this is. This is just randomly generated data.
So the near is always based on the max distance or max something.
Max distance, yeah. Let's give it 100 kilometers, and let's see how many records do we get. And we get all of them. So apparently 100 kilometers is just too much. Let's do 15 kilometers. 12 records, 20 kilometers, 20 records. So you can increase the range to get all the records that are within the vicinity of my point. So, how do you feel so far? Do you think it works for you? It's good, right? It's very straightforward, painless, at least. Like, it reads really well, where location is near the center point with a distance of this. It's very simple. You don't need to do convoluted stuff just to get this. Okay.
And you can use variables even on stuff like near and just change it according to what the user inputs.
Yeah. Again, you just make this into parameters.
No, like the near itself, like it decides like in what's near, but instead some other stuff. So can you make it like
Yeah, of course, because this is just a query. You can say, if the person wants to search near a point, do this query. If they want to search for, let's see if it's there. Yeah. For example, they also could want to search for intersections. Does this point intersect with this polygon, or does this polygon that I'm sending you intersects with this other polygon? And you can also do that. It's basically just like near. It has its own query syntax that you do, and it's very straightforward. But that's actually why you hit this mongoose reference. So, for example, you search for intersects, and you see it here. For example, query where the location intersects this geometry, where this polygon. This is a polygon. There's also a within function. So if this point is within that polygon, tell me. This is useful for try now. And it's, again, very, very, very straightforward.
But if you have a postal code,
Sorry?
if you have a postal code, then it's going to be an area.
Well, this doesn't work with postal codes. You have to know which postal code maps to which polygon. If you have a polygon, then you can work with it. This is actually a huge, huge problem for the real estate market, because when you want to search for an apartment in Kreuzberg, who knows the limits of Kreuzberg? There are actually two different Kreuzbergs. For people, it's like 36 and 63, I don't know. Like, there are two different Kreuzberg numbers that are around. So Curie 36 is because it's kind of at the center of the eastern part or the western part, whatever. So how people define the parameters and how governments define it are totally different. So it's a huge problem for those companies to come up with a polygon that can represent Kreuzberg. Or like Mitte. What is Mitte? Because there are some parts of South Mitte that people don't consider Mitte, for example. And you have to adapt the queries around that, otherwise people see unrelated results. So it's a huge challenge of mapping postcodes to polygons, and you do it by asking people. Like, you cannot take government official records for granted for that thing. Then that's very, very hard. Okay. So we also did this where we did the location query. Now let's delve into more analytics. Because people claim you cannot do data analytics with MongoDB. Like, that is just, not fit for the job. You need a relational database for this. And that's actually not true. And in order to have scalable data operations, you have to use a different methodology. You cannot use a relational database and regular SQL queries for running at scale. Did you ever hear something called MapReduce? Raise your hand if you did. 1, 2, 3, 4, 5. It's good. Yeah. Everything is based on a paper that's been published by Google. They said, we have a lot of data that we want to crunch, and we want to do them parallelly. We cannot do them one by one. It just doesn't work. And we are Google. We have infinite amount of CPU, so we can actually parallelize any task that we want. So we came up with a way to parallelize any type of work, any type of data analysis work that we want to do. And they said this is based on functional programming, and it's based on concepts called map and reduce. Now, these are also array operations, array functions, array methods in JavaScript as well. We have the map method that we already used, right? And we have the reduce method, which we're going to use. So What does map do? Can anybody tell me?
It creates a new array with each individual items in the array.
Yes. So let's say we have this 20 records here. Okay. This is the array that I have, and I want to, again, just what I did before, I want to create a new array that only includes the case IDs, for example. Okay. I do it by mapping this by doing R to our case ID. Or allow me to put this here. And run this, and then you only get the case IDs. This is the map operation. It takes an existing array of items. It runs each item in that array through the function that you give to it, and then gives you a new array. This is the function. I take in a record, and I give you case ID. When I do this for every item, I get a new array of case IDs. Okay? Now, the question is, does any of the records here depend on any other record inside this array? No, right? They're all individual records. And I'm mapping them individually, one by one. Which means if I have some means to parallelize this, I can. Like currently I'm doing it one by one. If I had 20 CPUs, I could distribute this task and they could all run in parallel. So each CPU would only do one job, one map job. Because there is no dependency. As long as you can read the records and you can map them out to, send them out to different processing units, then you can parallelize this as much as you can, as many as you can. Make sense? Now reduce comes into play here. Obviously this doesn't work for case ID, but let's get their ages. Requester.age. Let's run it again and let's see that we got the ages. Okay. Let's say I want to find the average age. How am I going to do that? Huh? Yeah, add every one of them and then divide them by the number of records, right? So let's reduce this then. I have an array of 20 ages. I want to reduce it to one single age. That is the average of them, right? This is where the name comes from. I have an array of 20 items. I want to reduce it, the number 20 to 1. I want to have one single record at the end. This is what I'm using reduce. And it goes hand in hand with the map operation. First I map the record to the age, okay? And then I reduce those ages. I do that reduce. Let's put them on separate lines. So when I open the parentheses, you can see the documentation. It says, give me a callback function that takes 3 values, or 4, depending on where you look at it. It will have the previous value, the current index, and the array in total. Now, if you have an array of 20 items, how can you reduce them? One good idea is to do it one by one. Because again, don't forget, the end goal is to parallelize this. How do I do that? If I tackle them, all 20 items in one go, I cannot parallelize it. I have to split the chunks into different stuff, right? So that they can work in parallel. So the good idea is if I work on pairs of values with the initial value and the next value. Initial value and the next value. Whatever initial value it is, if you can work with that and put the next value on top, then I can basically split this into different chunks and parallelize this. So what I'm going to do here is very simple. You said that we should add these up, right? And that's what we're going to do. I create a function with the, let's say, the previous value and the current value. Okay? This is a function. And what I do is I add them. Current value plus previous value. So for every item in the array, it starts with the previous value, which defaults to 0. So if you're tackling the first item, the previous value is 0, I add them, it's 15. Then I move on to the second item. The previous value is 15, the current value is 16, okay? Then I move to the, I add these up, it's 31. I move to the next item, item at index 2. What is the previous value?
31.
31. What is the current value?
16.
16. I add them up, it's 47. I move on. What is the previous value?
47.
47. What is the current value? 17. I add them up. What is the, and I move on to the stage 4. What is the previous value?
64.
64, yes. What is the current value? 17. You get the idea. And now if you have this operation, you see for item 4, it doesn't matter how many items were there before it. It just works on an initial value. Okay? Which means you can individually sum these up, starting from 0, and then still bring them together. Because you just do this again. You know, break this into 4 chunks, individually add these up together in parallel, and then bring those 4 chunks together, because you're still doing the same operation. You still have this, this reduce action, okay? This way you can also parallelize this task. So we have a map task and a reduce task, and we can parallelize the hell out of it. Which means we can build really, really fast, if we have the infrastructure, we can build really fast data operations. Because this is a very simple function that I'm just adding up numbers, but you can do whatever you want here. You can transform the objects into however shape you want, and you can put map, reduce, map, reduce, map, reduce, hundreds of them, and chain them. You can chain 10 maps and then reduce them. It all works. And this is basically a structure to do parallel work, which is impossible in a relational database in a SQL context. Even if you have a relational database and you fetch all the data, you cannot process any, no individual database can process stuff in this parallel fashion in like this fast. So this is a map reduce operation that you do out of your database, and you achieve higher speeds. Now, enough talking. This is a local map reduce operation that I'm doing locally on the on Node.js, on my own environment, which means I fetched all the records and I do the map and reduce operations in my own servers using my own memory and CPU. But actually, this should be the job of the database. The database can also run this for me, or should also run this for me. I'm going to show how, but first let's finish the example. We have the ages in total. Let's run it. This 533. What we need more is to divide this by rec.length. So whatever the array is, the average age is 26.65, which is good, right? Cool. Now let's make the database do this for us, because we can, and because databases are also good at this thing, especially MongoDB. So for this to work on MongoDB, I need to define JavaScript functions and transfer them to MongoDB, okay? Wait. Okay, it's recording. Okay, I thought it was not recording, but it is. All right. I will create functions and transfer them to MongoDB, which implies that MongoDB runs JavaScript inside, and that's true. It also has a JavaScript engine that can run parallel tasks. So I'm going to write functions here. They will be transformed to strings sent to MongoDB, and MongoDB will parse them and create them as functions. Okay. So let's first start with the map function. Function map. What does this do? Yeah, it gets a record and then sends out the age. Now, there is a special syntax for this. There's an emit function that is already defined in MongoDB that signals, whatever operation you do, in the end you do an emit. And we will emit the requester age here for the map operation. And we do this dot requester dot age. Why did I type this? Bless you. Hmm? Yeah, the thing is, this map runs for every single record. This operation will run for every single record. And this keyword will point to that record, that individual record. So I got the age of that that record, basically. All right, then I go and give it an object. Let's say age, this requester age. The first parameter is the unique ID that I'm emitting. And yeah, okay. I have another idea. What about getting average ages of each gender? Average age of all male, female, and other genders. Which is a little bit more complicated, but let's try. Okay? This is the reason this is important is, if you remember what I said about reduce, I was talking about chunks, right? That each chunk will be parallel. We need chunks to work on. And with ages, they're all separate, so it doesn't really require a reduce operation because every age is kind of unique. But we already have some buckets. We already have some chunks. Like we can use the gender for that. So what we're gonna do is for every gender, we create a new bucket. Like for male, female, and other, we create a bucket, and we'll run reduce operations on those buckets so that the three will run in parallel, and then we will combine them, combine the results. Okay. So this is the bucket ID, kind of the unique identifier for the bucket. So I'll say give the gender. So all the male people will go to this bucket, all the female people will go to other bucket, and so on. And we have we only emit their ages. We could also emit the whole document, but there is no purpose in doing that because we're already only interested in the ages. So I'm just emitting the age. All right. And then I write a reduce function. Okay. What does this reduce function receive as a parameter? It's a tricky question.
Whose age?
Age?
Yeah.
How many ages?
The number of genders, length of gender.
Yes, and think about the parallelization. Map operations will run in parallel for every item. Reduce operations will run in parallel for every bucket, for every chunk. So, how many reduce operations will be in parallel?
Length of chamber.
Which is 3 here in this application. So it gets the ID and all the values that are in that bucket. All right? And then you do whatever you do with it. For example, we will just have this here, this reduce function. Let's say return values.reduce. The values are these ages, okay? Values.reduce. We call it I and V, initial and value. Let's do it like this, I and V. And we want to sum it up, right? We want to return an object with an age, and that is the total of I.age plus V.age. Now, does it make any sense to you, what I'm doing here? This part.
I is the previous value.
Yes, I is the previous value, V is the current value, and the syntax is basically what we mean by value is this object. It's an object that has an age property, okay?
Divided by...
Wait, we're not there yet.
Okay.
First, we sum them up. Why do I have an object here?
Can you please repeat the question?
Why do I have an object here? Age, I.age plus V.age.
That has to fetch the age.
But why isn't it just a number like this? Why isn't that an object? The reason is, it is the same structure I'm emitting from the map. Like individual values. Reduce operation cannot decide on the structure of the objects by its own, on its own. In a reduce operation, you cannot change the structure of the objects. You are handed some I and some V, and you have to work with that. You cannot change the structure. You have to supply the same structure that you're receiving. So, yeah.
That means reduce has total dependency on map. Right now, in this structure.
The output of map, let's say. Yes.
Yeah. Okay.
Yeah, exactly. Now, beforehand, I told you that the initial value for the reduce operation would be 0. Would it work here? This is the initial value, right? I. But I expect I to have a property called age. Would it work here if the initial value would be 0? No, because 0 doesn't have any property called age, right? So what I need to do is I also need to give this reduce a second parameter, which is basically the initial value of this operation, which is an object which has an age 0. This is normally, by default, is 0, and by default you can omit it, but we can't in this case because we have a custom structure here. We don't work with numbers, we work with objects. Okay? This is a little bit convoluted and it's a little bit hard to grasp. But the underlying principle is actually very, very simple. Reduce cannot impose a structure on its own. It has to use whatever structure you pass to it. And I decided to pass a structure of an object, which is very common. You always do this. Okay? Now, what next? We have these numbers, and then what is the output of this reduce operation? What is the structure of the output of the reduce operation? Previously, it was a number here, and I was able to divide it by record length. Now, what kind of structure does this reduce give me in the end? Will it give me a simple number, or will it give me something else? Anybody?
Object.
Yes, an object which has yes, which has an age. Perfect. Thank you. Yeah, it's as simple as that, because what did I tell you? The reduce operation cannot change the structure. It has to work with the structure that you give to it. Therefore, it has to return the same structure. So it receives a structure with an age in it. It gives you a structure with age in it. And the number will not be 0, of course, it will be 533, the total number of all of these things. And then, in order to get the actual age, you have to do dot age, right? Because it will give you an object like total age is this reduce operation, and then you do return total age dot age over values dot length. Okay. All right. Now, let's give this to MongoDB, because why not? Case model dot MapReduce, and this expects an object with 2 fields, map and reduce, like this. And that's basically all. Let's run and see if this will work. Results. Yes, it worked. Perfect. Cool. Good work, actually. So we have 3 results. Female, male, and other. And the average ages, 31, 31, and 27. Perfect. This is called the MapReduce operation. This was a revelation in 2008, 2010. You know, people created companies that only does this in a scalable, monitorable way. So this is a huge leap in terms of crunching any type of data that we have. Because again, I can parallelize this. I can have parallel operations on map and reduce. And it doesn't matter how big my data is anymore. As long as I can throw more hardware at it, I can scale it infinitely. At least the map operation, and then the buckets for the reduce operation. So this is another paradigm of doing queries. And MongoDB has native support for this. One big trouble here is, since Mongoose converts these to strings and then sends them to the database for Mongo to execute, you cannot debug this. Unfortunately, it's as bad as that. Like you cannot put a breakpoint here, it will not stop here, because this doesn't execute on my JavaScript context. Otherwise, this would throw an error. There is no emit defined anywhere. It's hard to debug this. You have to run it on its own shell and get MongoDB logs and try. It's not the easiest thing, but still it works. Perfect. Now we have kind of 30 minutes left. I hope you're not tired yet, because I kept the biggest thing to the end, of course. There's one more mechanism that you have to learn about MongoDB. That is actual real data analysis framework that is used in MongoDB. I would love to say people love using MapReduce, but they don't. They were 5 years ago, 6 years ago, but now we have better constructs in MongoDB that can operate faster. So MapReduce is not the first choice when you want to do any type of query in MongoDB. But at least you can do it. So now not after you learned it, you can do whatever you want with MapReduce, and it will work in a parallel fashion. That's great. But there's a kind of a better way of coming up with averages, for example. Instead of writing iterative code, we'll do some declarative programming. And unlike SQL, this thing will be really declarative. Anybody knows what declarative means?
Before we start, one more thing. So next Thursday is Christian fast. That means today can be the last day for. I talked to Debugging people, so they are open. So how many of us are coming? Otherwise, it's going to be the last day.
I don't know. We have the study group, but I don't know when it is. Is it Thursday?
April 10th, and that's a holiday.
Okay. I mean, normally 3-4 people come to the study groups, so I don't expect to see everybody. But is it Thursday? I may be here. I may be here. I'm not sure. But I mean, I don't want to do raise your hands if you're gonna come to the study group because nobody does. So I don't know. But if this place is open, which means we can come to it, that's good. Did you want an answer for this?
Yes, I wanted to talk about that. Otherwise, this is the last time we are seeing the group.
No, if you don't do it on a holiday, we will do another study group. So there has to be a study group for this session as well. For you to not come. And because that's what it has been the case always.
But there's some are coming.
Yeah, some are coming. Some are doing some stuff, like again, 3 people. We'll see. Anyway, we can talk about this on Slack, but it's also true that after that study group, there is no more. So this is your last chance to get on board the JavaScript train.
What is the next course?
That's a good question. I don't know. I don't know if anybody will want to do a beginner's course again or another advanced course, but we'll see.
Another advanced course.
Huh?
Another advanced course.
Another advanced course. A further advanced course. Like one more. Why not? We still have so many topics that it's really hard to actually wrap your head around. Cool. Let's start with the approach, with the new approach. It's called aggregate framework. So MongoDB has very extensive documentation on everything that you can do with it. And also Mongoose has almost equally extensive documentation for everything that it can do with MongoDB. So one thing that we're going to use is the aggregate framework, and it's basically, if you look at the name, it's a way to gather multiple data points, aggregate them, sum them up, do some operations, to do some data science operations on them, and then produce a result. It's a structured way of doing this, not one by one, like normal queries do, but in a parallel fashion and in a declarative fashion, which is like CSS. You say, I want to have this, and it gives you that. You don't write, first map it to this and then reduce it and have the average and stuff. It has very, very nice constructs about that. So here in the reference, in MongoDB reference, you have aggregation pipeline stages and aggregation pipeline operators. This thing works in a pipeline. It's how it parallelizes stuff. What do you understand when I say pipeline? What is a pipeline? Come on. We can sit until morning until you give me an answer. What is a pipeline? Sorry? Set of steps. Yeah.
Like each of them is connected to the previous.
Yes. Exactly. So it's a set of operations that are applied in sequence. So for example, purchasing something on Amazon. You click the buy button, they ship it to you, you open the package, you use it. This is a pipeline. These happen in a sequence. One cannot happen before the other one, right? And it has to depend on the previous outcome. So MongoDB aggregation framework has the idea of pipelines. And you basically form your query in certain pipeline stages. So for example, one pipeline stage is the group stage, where you start out with, I don't know, 1,000 records, 100 records, and then by certain criteria, you group them. Like we did for the gender. We grouped records by gender, right? That was a group operation. And for example, you have a project pipeline stage, which is like the map operation that we had on the array operators. It takes in an object, in a document, and you can say, I want these fields and I don't want these fields. So you project another version of it. You take the case document, you project a version of it without the ID field, without the requester field, or only with the requester field, for example. That's why you use the project stage. And then you have the sort pipeline stage, where you sort the items. And you have the limit stage, where you say, okay, I had 100 items until here, and from now on, I just want to go with 5 of them. I limit 5. Since this is a pipeline stage, it's very important where you put the limit. If you put it right at the beginning, it just starts with 5 options. If you put it right at the end, it will do every operation and then limit the results. So it actually, the meaning changes when you change the place of the pipeline stages. There is also a match stage. Match is basically the same as our find queries. It allows you to do queries. Like you tell it, give me everything that matches for age, for example, between 24 and 30. That's a match stage. So ideally, you start with a match stage. You first trim down your records to individually what you're looking for, and then you group them, and then maybe you project them to something. You can group them again and run some operations on them. So these pipeline stages are kind of plug and play. And unfortunately, it's not very straightforward to talk about in like 30 minutes. You could do a whole complete university lecture of 14 sessions just about this aggregate framework. It's just as extensive, but it's also still very, very simple. And there is no ambiguous operation. There is no, stuff that doesn't make sense. Whatever you think should be there is there. There is an average operator. There's a sum operator. There's this match stage. There's this limit stage, and limit works with a number, for example, as you would expect. So it's very straightforward once you get into this idea of pipelines and then pipeline stages and then passing the result to one another. And they do a very, very good job of giving you examples about everything. Like, for example, let's say the match stage. The documentation tells you what to do. It also talks about the optimization. Place the match as early in the aggregation pipeline as possible, for example. That's one of the very good tricks that you learn from the documentation. Their documentation is really, really good. Like, you can read through it very easily. It's very approachable. And it has a very, very good example section for every pipeline stage. So, you know, match everything whose author is Dave, for example, here. And, you know, given these records, it will give you this thing. It also has combination of different stages. So, for example, match, much like we did, match all the scores between 70 and 90, or with all the views greater than 1000, and group them or sum them up. So it has a very extensive documentation that you should read. Unfortunately, people don't read any documentation at all. But much like Vue.js documentation, this is very detailed and very understandable. So let's write a new query. Record case model dot aggregate, and then by this command I start an aggregate operation so that I say, okay, I'm gonna do some aggregate operations and let's start a pipeline. Okay, I start my pipeline with this. I'll have a very simple pipeline, the one that I had before, by the breaking down by genders. If you remember, I told that it's actually a group, and see, you can also have graph lookup, and you can read the documentation here as well. That's a group operation, right? I'm grouping by genders. So that's a group pipeline stage. And the group stage expects an object with an ID field, and it expects you to tell something that's unique about this group. What is unique about our group? The genders, right? So every single record that's in the database will go through this group stage, will pass through this stage, and we will look at the requesters and the gender of the requesters. Okay? I put a dollar there to indicate that this is not a string, but this is actually a value, a field. So for every record, fetch the requester field and fetch the gender field of that requester. Okay? And this is your ID. Does it make sense? It's kind of straightforward, right? It's not exactly as straightforward as it could be, but it is. Okay. Now, again, every record will pass through this group stage, and it will have their IDs. Other than the ID, what other property do we have in the group?
Age.
Age, yes. Let's call it average age, shall we? Because that's what we want to calculate, right? We have the ID, requester gender, and we have the average age. Now, this should also be an object, and I want the average age of everybody. And it's as simple as writing $average, AVG, and again, I'm typing requester.age. So let's put this in a little bit more structured way, like this. Okay? Group everything by the gender and calculate the average age. It's as, unfortunately, as simple as this. I run this. Oh, I have to await it. I run it, and here you see 3 objects and the average ages is correct. See, it's very simple. This is the power of the aggregation framework. It's declarative. I tell it, hey, give me the average age. That's all. Like, give me the average value of this field. And it does. You group it by gender and you just, give me the average age. Now, let's use project. And let's remove the ID, for example, please.
AVG is already defined in MongoDB.
Yes.
That's why I picked it up.
Yeah. So, again, the project is another pipeline stage that takes in these numbers and then removes the ID field. Or you can do whatever you want with it. Yeah, please.
But why do we search by ID and then we remove the ID? I don't get the point.
It was just an example.
Okay.
The ID is currently the gender name. I think we can do this, but I'm not. Let's put it like this. You can also put gender here, okay? And also type requester gender again. So now it may make more sense for you. Oh, what's up? Field gender. Wait. Shall we try to project it? I'm not sure if this will work at all. Yeah, it did. Age. Yeah. So now I have two different project stages. I first grouped them, and then I said, ID doesn't look good, okay? Take the name gender and map the ID field to the gender field. And then, just pass in the average age. And then I remove the ID field. So you can have multiple stages in this thing. So I guess this will also, yeah. See, normally it has the ID field. And by adding a second project stage, I removed that ID field. So this is very simple data analytics. Like, give me an average age of all the people in my target group broken down by age, right? The same thing with the geolocation queries also works here. You can do stuff like near again. The syntax is a little bit more convoluted. I will not type it, but you can look it up. It's a little bit different than the one that we typed before, but you can still do geolocation queries here in this aggregation pipeline. I want to do another example. These are emergency cases, right? We have the open dates that range from April to May that I came up with. So I want to group them by week number. Let's see how many cases do we have open per calendar week, for example. Because we have the open that or created at field in our cases. How do we do that? Which pipeline stage should I use for it? Come on. I want to break it down by week numbers. Which pipeline state should I use it? Yes, group. Why? It's very simple. I'm not asking hard questions, do I? It requires an ID, right? What will the ID be? This is fun. What is the ID of each group? Yeah. Kalenderwoche, or something like that in German. Let's say week is let's open the field. Is this interesting at all? There is a week operator for fetching the week number out of dates. It's very straightforward. I say, give me the week of the open that date, and that will be my ID. And then I want to group the cases one by one, right? I want to group the cases by this week numbers. I say, okay, cases should be an array, right? And if I have single elements that I want to create an array from, what do I do? What can I do? Map works on existing arrays. If I have an empty array and I want to add more elements to it, what do I do? Who said that? Yay, perfect. That's the right answer. We do push. And that's another operator in MongoDB. There's a push operator. So again, what do I want to push here? Let's push the requester. So let's push all the requesters of all the items per week into something called cases. Okay, let's run this. I get 5 objects, week 15, week 14, week 17, week 13, and week 16. That's perfect. And the cases are the requesters of all those cases. This is okay, but this is not exactly what I want, because I don't only want requesters, I want every case broken down by week numbers, right? There's yet another special operator for it called $root, which means just have the whole object, the actual object. So again, when I run this, you'll see that I have week 15, week 14, whatever, all these 5 different operations. And then in each case, you see all the cases. So this is a very simple group operation by week number. This is very powerful. This is really powerful. But if you had month here, this is week, I can have month. And I use the same attribute, open that. Let's run this. Now I have 6 of them. This is very interesting. Watch. Month 4, week 16. Month 4, week 13. Month 5, week 17. Month 4, week 15. Month 4, week 17. So week 17 is actually split between 2 different months. Okay? When we broke it down by weeks, we had 5 items because we have 5 weeks, 5 calendar weeks. But actually one of the weeks is split between 2 different months. So when I add the month to the ID, then I add another dimension to my data. So I break it down by month and week number. I have 6 items because half of week 17 is in month 4, half of week 17 is in month 5. Okay, this is an interesting operation. All right, this is good. One last stage that I want to show you is the sort stage. It's good that we get this per week, but they are not sorted. The first is 15, and then we have 14. I want to sort it by week. And as you'd imagine, I do dot sort, and in a string, what do I type? Week. Where is week in? It's in ID. So it's, see here, it's underscore ID, and then inside that we have the week. So it's actually sort ID week. And then you see then it starts with week 13, week 14, 15, 16, and 17. Right? This is easy. It's kind of okay. It's kind of straightforward. Once you learn this idea of the stages and this grouping and this operators, this week, push, and there are like 50 other operators. And you can do very, very crazy stuff. You can store the text information in the document and the actual price, and then calculate the text price of an item in this aggregate pipeline. So you can do, break down your revenue or tax expenditure right with the aggregate framework. Because much like you can do an average, you can do multiplication, you can do a division. You can multiply the tax amount with the price of the item to get the actual cost. So it's very, very flexible, and it allows you to do almost anything that you want with data. Okay, this is basically all I'm going to tell you about MongoDB and its aggregate framework. Again, this is a very brief introduction. Just read more on that, and you'll discover a whole new world of data manipulation. I'm actually using this extensively. I'm running huge data operations with this aggregate pipeline with 600 million records. We are tracking what people watch in terms of series and movies and TV shows and stuff, and we kind of have every single watch record for 400,000 users, and we're crunching that number to find, for example, how many days does it take for a person to binge watch Game of Thrones season 4, or for how long did they consecutively watch it? Did they watch it in a single sitting for 13 episodes, or did they split it in 2 days? What is the average distance between two groups? I watched 4 episodes once and 8 episodes once. What is the distance between those 2 sittings, 2 watchings? And it just works. It works really, really well because it can parallelize everything here. It's built for that. And yeah, it's really fun to work with as well. So for the homework, which I know nobody will do, but I'm still gonna try my luck, because why not? The homework is to come up with your own template, to generate your own data. It could be anything. Think of any scenario: school grades, work, I don't know, anything that you can come up with. Sports results or Guinness records or anything, and generate 100 items and then do an aggregate query on them. You can do average, minimum, maximum of values. You can do multiplication, as I said, in like tax, revenues. You can have Bitcoin prices, for example, and calculate how much money you lost on Bitcoin through MongoDB again. So basically, it's fun to work with, but this is the homework. I expect you to do it for this one last time. Yeah, that's all. Thank you for joining me today.